James Carpenter, welcome to the show. How are you getting on today?
Doing well. Thank you. Thanks for having me.
You're welcome. It's a bit early for people in Europe. We're trying to hit people in the Middle East today, and it's a bit late for people in the United States, or early. Well, actually, a bit early for you, James.
Yeah, it's a bit early. It's pretty dark outside, but that's
Yeah,
okay. Happy to be here.
thank you, James. So you're a certified LeSS trainer, not many of those in the world, and you have a large-scale Scrum huge, our LeSS-Huge case study. But before we get into the case study, a lot of people will probably be wondering what is less actually the basic framework. Can you maybe fill us in on that?
So sure. So less, you often hear it called a descaling framework. It takes the approach that let's simplify the organizational design, and as we do that, and we get the people doing the work much closer to the people using the product, and we focus on technical excellence, and we avoid a lot of the traditional problems. So specifically, less is explicitly optimized for adaptability at the system level, at the global level, and delivering the greatest customer value possible. And the organizational design elements that are within it a lot are aligned with that goal. Less less basics, it has a single product backlog, even though you have multiple teams. It has a single combined sprint review, and then you have, as far as retrospectives, you have, it is based on Scrum, so these are, it's an expansion of Scrum in that regard. Your retrospectives, you have a team level retro as well as an overall retro. This tends to work until you get to about 8 or 10 teams, and then it just becomes too much burden on the product owner because of the cognitive load. And this is with the teams are actually doing most of the elaboration of the product backlog. You can think of the product owner as giving mission intent, and this is probably someone who's like head of product management. This is not a business analyst role in disguise. This is a real product owner. Um, and the teams are, you know, true feature teams. I think what you like to call a slice of cake,
Hmm.
right? So they're cross component, cross functional teams, co-located, all of the things you would see in the less rules. Unfortunately, although this is best in terms of optimizing for adaptability, what happens at some scale is eventually it's just too much to get too much bigger. And that's when you find yourself with less huge, which is the next picture that you have. And this is simply you have an overall product. Have a product owner called product owner. It's not doesn't have head chief product owner or head product owner or overall, but it is effectively that. It is that, and then you have area product owners that are responsible for these different requirement areas. Now those are not baked into the organizational design. They're intended to be fluid. You want your requirement areas to be able to fluidly come and go. So if a requirement area was to be collapsed, an area product owner would go back to doing product management stuff. It's not like they lost their job. There's tons of product management stuff for them to do in the first place. But there are no, in less and in LeSS-Huge, there is no product management organization. There are no specialists outside of the team. There is the testers, the software engineers, the UX expertise. That's all inside the teams.
Yeah, James, one of the things I like to explain about the basic less framework is there is one product owner and one product backlog, and there's a very good reason for that. So, for example, if James, you were working on the $300 million item in your team, and
That's
the next item on your team is $290 million, but you can't afford to work in it because you're focused on the $300 million item. But I'm in another part of the product, and I've got my own little backlog, and I've got my own product owner in a different world where it's not less. And I can only see the $1 million item, and I'm thinking of moving on to the $500,000 item. I can't even see that I should be helping you on the $290 million item. And even though my team really sucks at the kind of work that you do, for the good of the product, it's better, even though we're less efficient at doing that work, it's better that we try to start that work, try to learn that work, maybe get some support from your team so that as a product group, we can be more adaptive. We can really maximize the value across the product group. And so it's a lovely way of simplifying product development. And of course, as you mentioned, at some point the product owner's head probably explodes a bit because yeah, we can go up to 8 or 9 teams. There's no magic numbers. Whenever it's feeling uncomfortable, it could be 7 teams, could be 13 teams. And the general advice is stick with less if you can and avoid going to LeSS-Huge. But there comes a point when you do need to go to LeSS-Huge, and that's kind of the situation that you're in, James. Is that right?
uh, we were certainly getting there, or rather, what happens is when you start an initial adoption, you actually in a really huge context, and so the context we're going to describe had like 4,000 engineers.
Yeah.
You start with an initial requirement area, and you get that working. Well, when you're getting that initial requirement area working, it's almost like you're in a less basics situation.
Yeah.
It's not until you bring on that second requirement area that you kind of are LeSS-Huge. So, from one perspective, you could say that my less case study covers a less basics case, but in the bigger context, it's in something that is definitely in the huge situation.
Understood.
So,
Okay. So in this particular case study, James, what was the product and what was the industry that you're in?
so the product for this client, the client itself is anonymous, but it's basically a server infrastructure on a forklift on a pallet. So if you're Google, if you're Amazon, you will build up massive server farms of stacks of compute of some sort, as well as some sort of storage. However you're going to do your network attached storage or whatever type of storage you're going to do, you'll have some sort of infrastructure on the top to manage all of that. And because you're Amazon, because you're Google, that will all be bespoke software. Or maybe not completely bespoke, but it will be an amalgamation of stuff that you pull off the shelf and put together, and that you spend a great deal of engineering capital knowing how to do. On the other hand, if you're an investment bank, if you're a Department of Energy, you really want an easy button. You want to do the equivalent of walking to the Apple Store and say, I want all of this, all the software that knows how to manage it, all of the hardware that I know fits together like Tinker Toys, and I just want to buy that as a big thing, and I'll write some monstrosity of a check, multi-million-dollar check, and you'll deliver me this forklift of stuff, and it will all work together. It happens to be a blade architecture, so that it's a very dense architecture, so you get a lot of compute in a small space, but it's compute, network, and storage, and then as well as all of the infrastructure hardware all of the software, single pane of glass stuff to manage it. And if there's a problem, this is slight hyperbole, but not by much. If there's a problem and the servers are giving you lots of trouble, there'll be a guy that falls from a private jet down in a parachute with the motherboard that you need. That's the kind of support you're asking for, because these are often deployed in environments where every minute that it's down costs horrendous amounts of money, and so the clients of this company pay huge amounts of money for this. And this is this is almost like I want to say a commodity product, but it's they make a bunch of them, right?
Mm.
So they don't make as many as you would for, iPhones, right? It's not that market, but there are a lot of companies that buy this kind of product. So it has that mass production aspect to it.
Mm.
And there are competitors that sell similar products, but there's only a handful.
Okay, so it's a serious scale then. So on a lot of intensity, I'd imagine as well in the support of that product and due dates and so on. And I like to talk about, you mentioned slice of cake earlier. I like to explain, I know in less they talk about feature teams and component teams, and I prefer the expression slice of cake team, like middleware, front end, back end, all in one team, or a component team. Maybe there's one layer of that. But you introduced a new expression in your case study, which was extended team and expanded team. And I think what you're trying to do is you're trying to get the layer of cake teams progressing towards slice of cake teams, if you like. And this is with a new terminology that you created for this case study to illustrate that there's a journey to get to that place. Can you tell us a little bit more about that, James?
Yes.
Extended.
So this is when products become as large and as complex as this kind of product. Again, thousands of engineers. The reality is there's components within components within components. I mean, so it becomes a question of what is your boundary. Now, you'll actually see, unless it talks about, there's a guide and talks about what is your product boundary. What's interesting about this case is that the real product, what is the natural product boundary? Well, that's the thing on the sales brochures. That's the thing that the salespeople are selling. And it's very obvious. It's this whole thing that's on a pallet. And yet, where we had buy-in, so there's a lot of power politics that are coming into play with this case study. Where we had buy-in was on the, quote, hardware side, which didn't really go all the way up through the system the way that I would hope that it would.
Hmm.
And yet, even in the areas that we had support, all the same complexity of multiple layers and wanting to be more vertical slices, all of those dynamics were still in play. Now, in terms of LeSS, there is a term, and it's defined in the LeSS books, of an extended component team. So whereas a component team is responsible for, where a component team is responsible for just their component and testing their component, but their responsibility kind of stops there, an extended component team, in the words that Boss and Craig used, is they're responsible for doing changes to their component, but they're also accountable for testing, for the testing of the component in the system as a whole, right? So although they have responsibility to validate that everything works end to end, they only make changes within their component, and that would be an extended component team. But then the question is, so what happens when, as this component team grows and strives towards becoming a more slice of cake team, to use your words, or and now it's really not one component, it's multiple components, right? So what is that? Well, Craig and I didn't know, so we knew we had to coin a term, and the term we coined was extended component teams. I believe that's what I used. And that is to say, it still has the end-to-end validation accountability of an extended component team, but this is really an expanded component team. So it's an expanded component team in the sense that it's not just one component. So that's a little bit of wordsmithing to the way I originally worded it was to say that I had different product boundaries, but that broke the underlying concept of the truth is the real product was always super clear. It's this whole thing that's on a forklift, right? And so as to not pollute the product boundary term when it was so crisp and obvious what was the obvious product here,
Yeah.
we coined this new term.
So in the case study, you mentioned a person called Trent Gambale, and he was running the project management group within the MCS division. Not sure what MCS stands for. And then there were basically,
Modular compute system.
oh, thank you, yeah.
Yeah.
And basically there was maybe a dozen or so project managers in there. So I was thinking, I mean, there's wonderful project managers out there, but often when you get introduced uh, into a company by a project management group, it's like turkeys voting for Christmas kind of thing. So like, how did that go? That introduction.
So, so that's interesting. So, and it's a great question. The vast majority of the engineering here was managed by what were effectively team leads and management of team leads. So it was almost entirely managed by the engineering staff. Trent only had like 6, maybe 12 people reporting to him. And every one of them was, you know, value add. I was very impressed with the people he had working with him. This involves, so this has a serious hardware component to it as well. Now, the way the hardware works is that you spec the hardware, and then you, like if you want a board made, you can send that to a chip fab, and they will make you a short run boards. If you want a cabinet, you draw out the sheet metal design, and you send it to a shop, and they give you, and what comes back is all the fixtures, all the cabinetry, all of that stuff, right? So the industry to produce the thing that you want is there, but just like SpaceX, they may not actually do the machining; they send the work to a machine shop. But they're still designing. You still have engineers that design the CAD files that go to the machine shop. So some of what's happening here on the hardware is equivalent to the engineers that are working here design the CAD files that are then sent off to the manufacturer to do the production of that in a short run. And so there is, multi-million-dollar hardware coming in and out of the company, every month or two. And then another month or so later, that's a doorstop that's a piece of junk because it's just an intermediate artifact as you develop this product. And so, as you can imagine, it's extremely expensive to develop this, not just because of all the labor, but because you have this hardware coming in and out. And a lot of what Trent's people did is manage that inflow and outflow of this hardware, which, I don't have a problem with traditional project management. I have a problem with traditional project management applied outside of the realm that it's good at. If you wanted to build a skyscraper, a project manager would be a heck of a good thing to have. So this wasn't quite a normal situation in that regard. And then the other thing that happened is Trent basically, he and I would kind of talk about where should I go, what would be a good target to go focus on, and then he'd let me go. And I was off leash, and I just went and did that, and I'd catch up with them now and then and kind of give them a heads up what was going on. But I think I maybe met with him once a week, and we'd talk for 30 minutes. That was it. He was also wonderful at political topology. So if I had a question about, what is the political landscape going on, what's happening here, he was one of several people that would help fill me in as to, help me find my way through the political landscape.
Sounds like an ideal partner. I write about that a lot, that when executives bring change agents like you or me in, that it's important that it's like a partnership, and that if you, James, understand how LeSS-Huge works and all that kind of stuff, they understand their own context. They also understand their own political domain as well. And so partnering together and really working together, because it's difficult. Change is already difficult, isn't it? So it sounds like you had a great sponsor there.
Yes, I did. And then much of my partnership was actually with, like, the bulk of the case study covers a less like adoption down in the deep down in the caves of BIOS development. And there I had a director who I spent, day to day. There's not much that we didn't do together. And so that was, it was Mitya is his the anonymous name in the case study. Mitya and I, we trained up the teams together. We launched teams together. We dealt with various impediments together. And it was true that I was also, the case study covers, before I started working with Mitya on the BIOS area, Trent and I were looking for an initial. So one of the parts of the charter was, let's go look at the existing Agile parts of the organization, groups that claim they're doing Agile, and let's help them where it makes sense. And as I did that, as is not uncommon, everything that was, quote, Agile was really Agile in name only. And there wasn't a single example of any team anywhere of these, 4,000 people that was anywhere close to a proper team. And so we looked for an opportunity to show what would, a proper Scrum team actually look like. And this is just single team Scrum. We're looking for a kind of a context to prove that. And so that is that diagnostics product there. It might make sense to kind of give an overview of the architectural topology of the product, just so we can kind of
Yeah,
ground your questions.
that'd be cool. Thank you. Because I wanted to ask you about the feature team adoption map in the BIOS group, because that's a concept that people who aren't familiar with large scale Scrum mightn't be familiar. So wherever you find it
Okay,
easier to start is fine with me.
so can you show the diagram that I've got up, which is the
Yeah,
overall with the
sure.
big orange,
Yeah,
the figure one?
yeah. There you go.
Oh, and so by the way, for people who are watching, please feel free to follow along. You can watch the case study. It's on the LeSS website. It's under large server hardware company. You can also get to it from my website at agilecarpenter.com and just look for the graphic that has the timeline on it, and that eventually will get you there a few clicks in. So again, as mentioned, this entire product is, the whole product on a forklift, on a pallet. And down here you have a blade infrastructure where you have a bunch of blades that are put into this chassis. And the blade is not unlike the motherboard in your own computer in many ways, except here you have, a whole bunch of them in a slid into the chassis. And then there is of course, there's attached storage of various flavors. And, again, it's kind of tinker toy. You can kind of, do a variety of configurations there. And then up at the top, there is this administrative function, which is sort of single pane of glass to monitor the whole thing. And if you're familiar with, say, how VMware works, where you might move a node, you might move a virtual machine across physical nodes, and it kind of auto-magically migrates and all of this. You can think of this does that at a hardware level. And even though people actually often run VMware on top of this as well. So it's very common that when this is installed, there's VMware running on top of this. But even this by itself, running on bare metal, it can kind of migrate work across. From a software engineering, hardware engineering hat, it's interesting to understand that if you get up here, when you're looking at this, the modular compute systems GUI or the command line equivalent, this is stable middleware. This is middleware running on stable hardware. So it may be sold as a network device that, and goes and slides in, but, fundamentally it's a Linux box, and with a bunch of middleware, instead of being in Java, there was a little Java, but mostly this was C++. But, it's got an operating system. This is middleware. It just happens to be managing a bunch of hardware, but it's no more involved in some ways than trading system development I did when I was doing more hands-on work. In contrast, in order to be able to instrument, so there is a node controller. So anytime that this high-level GUI wishes to interact with a blade, what happens is there's the thread of control, or the thread of the messaging, goes down through the chassis controller. It goes into the node controller, which is an always-on, low-power chipset stuff. And that's, not quite middleware. It's low power. It has the low power requirement. It only gets, I don't remember how much, but very little power, because it has to stay on all the time. And then that in turn talks to the BIOS that's running on the main Intel CPUs. You could think of the node controller as like the part of your TV when you go and you turn the power button on and it still comes on, right? There's something there that's always on, just enough to be able to let you cycle the thing and all that. So that's always there. Okay. In order to support the level of instrumentation and control that is required for what this overall system can do, this is not off-the-shelf BIOS. So first off, the BIOS is the stuff that runs and warms up the chip before the operating system is even run. This is there is no operating system. As far as development, it is cross-compiled and deployed to target. If you're trying to get early information out of it, you can be lucky to get a serial connection out early on in your debugging steps. The hardware is flaky as can be. So unlike up here where it's super stable, down here, Intel or AMD, depending on what you're getting ready for, Intel will ship you early chipsets that are not in mass production. These are just prototype chipsets, and they give them to the OEM vendors up front. And sometimes the problem is actually in the chip. It's just that it was built wrong, or it was just a defective chip. That happens too. And then the other thing is that BIOS itself, just like a Linux operating system as an example, very complex. There's components within components within components within BIOS just by itself. And so they would go to an external vendor, and this external vendor would give them a copy of BIOS that they would update every few weeks. And then this company that the case study concerns, they would go in there and they would make changes to that BIOS to customize it and add the necessary instrumentation and make whatever adaptions, because the truth is, these NIC cards you see over here, well, they weren't normal NIC cards. They did all kinds of fancy stuff. This is not, although this may be built off of an Intel reference board design. Okay, they've done fancy stuff, and you actually have to tune how the BIOS accesses the RAM, because if you access it too fast, the speed of light is a problem, and you can only access it fast enough. Those electrons have to make it back. But if you but you don't want to go slower than you have to, because then your access times are not as good as you want. And so there's all kinds of, low level voodoo that's going on down here. And I spent most of my world in a middleware land. So I slung Java and Python, and I actually taught myself OO and Perl, which is an odd place to do it. And I did that for about 15 years. So, I don't know the firmware world as an engineer. I know it as a coach. I have worked in a few different contexts where there's serious hardware involved, and I've learned a lot. But I've never had from a time prioritization perspective, since I have been involved with this type of context, I've never had a situation where I had the enough time priority to sit down with an engineer and basically join the team for 6 months to a year and a half and become more competent at hardware development than I currently am. So again, what I know is, middleware world. But there's a lot of overlap.
Thank you. And you mentioned in the case study a feature team adoption map in the BIOS group. Would you mind flashing that up for us?
Okay, so let's talk about if what you want to. I think what you're asking is to understand feature team adoption map, and the easiest way to understand that is to look at this initial diagnostics team that we set up. Mm-hmm. So we were looking around for, how do we demonstrate what a proper agile team is capable of, and there were teams that were agile by name, but in practice, nobody was. And so even before I got into the BIOS work, which is where the bulk of the LeSS study covers, there was an opportunity to build a diagnostics platform that this never had. I don't know why it never did. They were losing, gazillions of dollars every month in returns, way less than it would cost to stand up a team to solve it. And so we pulled together a team where, although most of the development was in a custom boot image that had all these various hardware tests, you would have to be able to go into some of the custom firmware that's in the NIC, some of the custom firmware that's in the BIOS stuff, and the chassis controller, the node controller, and you'd have to make small changes in order to add instrumentation. And so we pulled together a team that could do that. And this diagnostics had to cover all hardware generations of the product, because not unlike here's my ancient iPhone 6 Plus, Apple has multiple generations of the phone out there. And even as the software gets updated, the older versions of that hardware have to be supported, and they are out in the field, right? So this is not an on-premise deployment situation as it would be, say, you work at a bank, you have a trading system. Well, the good news is you own all the servers, you own all, you can do hot deploys, all this stuff, good stuff you can do because you own that environment. This is not the case. These are on-premise systems, and so you have to be able to support previous generations in the field. So there is a concept of a feature team adoption map that that LeSS has, and the point is there's two axes here. So first is on the x-axis is the degree of cross functionality within the team, and in the terms of cross functionality, we were referring to things like writing C code, doing testing, doing UX design. Each of those are different functional skills, regardless of what component you happen to touch. So cross functionality, the way that Craig and Boss use those terms is very precise. I've never seen them used as precisely as I've seen them used in LeSS. And that doesn't mean that it's right or wrong. It's just like if I go to see you in London, John, and I order chips, well, I need to know that I'm going to get what an American would call French fries, right? and it's not that like, well, why do you call them? It's not like there's anything wrong with calling them chips. It's that you just have to know, oh, I'm in
Yeah.
London, so that
Yeah.
means that chips means French fries. And when you're here and you say chips, you have to know that you're going to get, potato chips, right?
Hmm.
Or, fried flat
Yeah.
round things, right? So here, when you read cross-functional in the less books, they are not referring to it touches multiple components. They are talking about, like the different types of skill sets or trade craft that would be needed as you do your as you do the work. In the same way, cross component would refer to, touching multiple components. And in terms of a feature team adoption map, you're looking at what is the scope of that cross component work. So a very narrow scope would be just that code, uh, just one file, right? Just different people know how to touch different files, and then you might have, well, different people know how to touch. There's a team that knows how to touch that subsystem, right? Component A, and another team does component B, another team does component C, and then you could have a team that not only do they touch different files, not only do they touch different components, they actually you know, cut through multiple subsystems. And of course, this would go all the way up to, what does the end customer need? So this is the concept of a feature team adoption map. And it's not necessarily static because you might actually have, well, this is the boundary we can start with, and here is the boundary that we can grow to. Now, this just has the initial boundary that they started with, but you can see that in terms of this slice of cake, as you mentioned, using your words, or a feature team in terms of in less words.
Hmm.
This was a feature team from day one, and
Sure.
because we went and found that.
So one of the things that I noticed in the case study was that you didn't really hold back at all, and I was thinking, how did you manage to do that? But it's more or less an anonymous case study, is from what I understand.
Oh yes, all the names are fake.
Yeah,
It's not called the modular compute system; it's called something else.
yeah,
Um,
yeah, yeah,
so, but again, there are multiple companies that make this kind of thing. This
yeah,
is yeah.
yeah. Because one thing that I noticed was in the timeline, there was layoffs at the end. The timeline for the change that you had, and you had you had month zero when you were kind of introduced, and then when people left and all that kind of stuff. Yeah, this one here, and then at the end you had layoffs happened, and so what often happens when I go into a company is the sponsor isn't always as open as maybe they could be about their real intent. That they want to cut jobs as part of this change. Of course, they should never be conflated. Of course, agility is about adaptiveness and about responding to market needs, not about cutting costs. As John Seddon would say, you cut unit costs and long-term costs go up. But what was your sense in this case study? Do you think it was always the goal that layoffs would happen, or was that coincidental to this case
So
study?
I don't believe that was the goal of the original SVP when I was brought in.
Yeah, yeah, okay.
Um, So my biggest advice is don't lose your key executive sponsor 3 months into your gig.
Yeah, because that happened, right? That made it a bit
Yeah,
difficult.
that's
Yeah,
what happened.
yeah.
And this organization was in this division was in distress, in the sense that um, it used to make mountains and mountains and mountains of money, and now it was only making mountains of money, right? It wasn't making multiple mountains of money. It was just only
Mm.
making really really big piles of money, and that wasn't enough because they were used to making bigger amounts of money. And I think the original SVP was under pressure to solve that. Um, this was an engineer's engineer. I was so privileged to have him as my executive sponsor. And one of the things he made very clear to me when I first time I ever sat down with him was, he said, James, this is not really about what you can do for me. The question is, how can I help you? And you let me know what I can do, and I'll do it. And he was very clear about that, and followed through on that. That was very well supported throughout. Um, at some point, because of, you know, let's call it the holding company that
Yeah.
holds these divisions. That's not quite true, but it has elements of it. Um, uh, at some point they sent in an SVP who was more of a business hat. Now, this is a very technical product, and so when I say someone was less technical, they still were pretty darn technical. So it's not take not
Mm.
technical as a with a grain of salt, but definitely more of a finance focused. Let's do what we can to right the ship in terms of finance. Not to say that the first guy could not have done that. I think that would have happened, but for whatever reason, there wasn't much patience, and I don't think that first guy had been there long himself. I don't think he really was given a lot of a chance to be successful.
Mm.
But
Yeah.
and I
So
don't know what was the level of interaction I had with the second person was just never anywhere, was not on this, almost non-existent compared to my level of interaction with the first person. And looking back, I have to wonder if that second SVP, always expected to do massive layoffs when the day was done.
yeah.
And I don't know if I would have been brought in had that person been there, when I arrived. But the reality is, these monstrosities of an organizations, they have a momentum of themselves. I was there. Things were in flight. I was, doing good stuff. And I was left alone. And not only was I left alone, the truth is that, like, many of the things we were doing were being celebrated. While at
Mm.
the same time, other forces were eroding the very art and trying to denigrate just how much better the stuff we were doing was because it made them look bad. So there's a lot of interesting dynamics. If you read the case study, there's a series of organizational design where you have when I started, I had this very supportive SVP.
Yeah.
The BIOS group I ended up doing most of the case study covers had a hardware VP, but there's a whole lot of software in the hardware.
Yeah.
And it's with Mitya that we did all this BIOS work. But we had a software VP who was sort of passive aggressive against it. And I think with time, had I maintained my original SVP, I think some of this would have been dealt with. But got a different VP, who was kind of neutral in behavior, a lot of lip service, but I didn't actually see nothing like I had in the first to start with. And yet we were still okay as long as I had that hardware VP and I had Mitya. We were okay in the BIOS, and the work we had done up in the diagnostics was up in here, but still, what had happened is this VP had told all the reporting chain, leave this group the blank alone.
Mm.
And because of that, they had. And so even once that SVP left, it took a little bit of time before they were willing to go mess with that diagnostics team. But down in the BIOS, there was still protection until eventually that hardware VP, towards the end, that hardware VP left because there's all these layoffs and they ended up going to what was going to be a startup. And then, of course, everything starts to devolve real quickly once that happens. And if you look in the timeline, I'm not sure if that's on the timeline, but somewhere in here is when that happened. And the layoffs didn't happen much longer. So a
Yeah.
lot of stuff collapsed.
I wanted to ask you about technical achievements because one of the things that I kind of gleaned from the case study was there was a lot of traditional management around you, and it's almost like you were in a bubble, if you like. It was a big bubble, I think, but it was a bubble nonetheless, and you were trying to do your thing with agility, and You'd Mitya as well. In less, they've got this thing called temporary fake product owner, which sounds awful, but actually it's a deliberate tactic to maybe avoid the business stakeholders, the customer, from seeing the chaos when we do the initial adoption, and then when things calm down, we can take over. So you good support, you good air cover with Mitya doing the temporary fake product owner, and you got involved yourself being the scrum master in this. But I noticed that you made a lot of progress with technical achievements, so like technical quality, and I'm kind of curious how that happened, because ordinarily you might need to bring in technical coaches or something like that, or you just need to get the space. How did you manage to get that to happen, James, where those technical achievements really happened in terms of high technical agility?
So, so there's a lot of elements that feed into that. So first is, I come from a very hands-on software engineering background all my career, right? So you could claim that I'm a technical coach in that regard, or at least I'm a very rusty one.
Yeah, got it.
Another aspect is there's not anyone at this company that's a dummy. These are a lot of these guys have master's and doctorate degrees. They may be in a situation where they're being mismanaged a bit, but they're all super sharp. And by the way, that SVP I'm talking about, that was like an IIT grad, which is like the MIT of India. So this is the kind of brain power that I'm sitting with. Oftentimes, if you create the right context, the people, you just have to remove the impediments that have been preventing people from doing good work, and then they'll start doing far better work. So that was true in two places that come to mind. So first is this initial diagnostics team. We were doing automated unit tests by the first sprint, and they'd never done them before. And when I helped launch the team, we made sure that I worked with them and I said we really should do unit tests, and that is to say, individual function, individual method has a test that tests negative and positive cases, not a bench test, not some high level integration test. We were doing just integration unit level test, and we wrote a definition of done that we came up with. This is a few versions in. And we initially started with just the Python. It had some Python code in that diagnostic, just the Python code. And that's what we did by the first sprint, is we were doing that because all the tool chain was there. To do unit testing for the C++ code involved a lot of changes to some make files, and we had to go find some tooling that would do the job as far as the unit test harnesses, and the test doubles were harder to figure out because it was this weird thing that it is. And so that took them 2 or 3 sprints before they had that in place. And then as they would do that, they'd improve their definition of done. But these guys that you sit in here, we created the right structure drives culture. If you want to fix the culture, you can talk about cultural change all day long and nothing happens. If you create a structure that is aligned with the culture that you want, you can get vast improvement almost overnight in terms of, in company time. Within a sprint, these guys are doing unit tests, never done it before. And I did some pair programming with one of the gentlemen here, and or 2 or 3 of them, and helped them through some of the initial hurdles. And then they're real sharp, and they run with it. Now, in terms of this thing, which is much harder, there were problems. So we'll kind of change scope a bit. This architecture is they're making changes to the BIOS code base. That's as to these BIOS teams, they're making changes to these BIOS code bases. That is a third party provides it. They come back with a dump truck every few weeks and provide the newest version of their firmware that is being evolved to work with the evolving non-production Intel chipset, right? Because so the hardware is evolving from one third party, And a second third party is building BIOS that works on this. And it turns out with Intel, like there's two companies that produce BIOS for Intel. AMI is one of them, and the other one's somebody else. And basically, everybody buys their BIOS from one of those two guys. And in this case, they bought it from AMI. And there's only like 1,000 BIOS developers in the world or something. It's like it's just a tiny market, and the tool chain's really awful because it's ancient and no one invests into it because it's such a tiny market. So they had been making changes by going into the code and just directly patching the code and not making use of any pluggable layers to do that. So every single time we had a new chipset, they basically had to do copy paste reuse the way they were doing it. And it just made it terrible. So it meant like every time a new chipset comes out, it takes another, year and a half to be able to be ready for it. And when these teams were forming up, I'm there kind of guiding them and all, but most of what you see here on this this figure 21, this is stuff that they came up with, and I'm prodding them a little. But one of the key things is no core changes, and what that means is no changes outside of that pluggable layer, if at all possible. And that eventually evolved into a more, carefully worded version that they came up with. But
so just on the definition of done, so sometimes the more items I see on the definition of done that I see, it can give us an idea about how complicated or how complex the work is, but also can be an indication of trust as well, how much trust there is in the system. So how much trust was there within the bubble that you had because sometimes what can happen is definition of done almost becomes a roles and responsibilities thing. You said you do all these things instead of actually what Scrum intended, where you're delivering a high quality product. You know what I mean? So what were the trust levels like, James?
So the trust levels were great. I don't think I've seen exactly the dynamic you've seen. I think some others have. I reflecting on your comment, I can reflect on a comment that I heard Boss make, where that might have been the case for him, which I could see you've experienced that. The situation I typically experience when teams are new is that they've never actually done good before. And there's not commonality of mind within the team as to what good looks like. And the only way that you really get to the point that everyone is really on the same page is the teams have to talk through what good actually means. And that edges yourself towards a rather long definition of done. And then there is a balance between, at some point you get a definition of done that's so big that it loses its utility.
Yeah.
But I've seen way too many definitions of done that in my mind are fuzzy. And they're so fuzzy that like people can bend the rules to mean whatever they want it to be. And, and actually, it actually can be used by the team as a defense against the pressures they're under. Because if you find yourself in a situation where estimates are treated as commitments, or that is to say the contract game is being played, the pressure is, well, why didn't you get all these things done that you hoped, that you planned to get done? And what you want the team to be able to say is, this is empirical process control. We don't know exactly how much we're going to get done in any period of time. But what we do promise is that what we commit to the company and to each other to do is we promise that we will always do the best job that we know how to do. We won't promise you exactly when we're going to get that slice done. But we promise you that we're going to do it to the best of our ability. And this is what we mean by good. And so, so I suppose that wasn't the case. And I didn't feel that there was like a trust problem here in this
Yeah,
case.
yeah.
Although I could see how in some cases, if you had a low trust environment, you might, say, hey, which one do you want to cut? And they're going to go, well, you don't know. We're not the experts. We're like, yeah, exactly. We're the engineers. This is, we don't want this. Some of these systems can kill people, right? I mean, you build a system that controls brakes on a car. If it doesn't work right, people die. And I don't care that like it's not out in time. I don't want to have some child die because the brakes didn't work. At some point, we have to focus on building the job right. And one can talk about, should it handle, some non-functional requirements like should it handle 1,000 transactions per second or 10,000 transactions per second? What is okay? That's a business call, and we can negotiate what makes sense there. But there's a lot of things, and I think things like you check it in and it doesn't have good unit test coverage. That's just irresponsible. You check it in, it doesn't have integration test coverage for the things that the unit test can't cover. That's irresponsible. So at all levels, this thing should be built well so that you do the job once, it goes out and it's stable. And then when you need to make changes, if you have that safety net of a mature and fast test harness at all these different levels of your test pyramid, then you can make changes very rapidly. And so from what is in the best business interest, is to do this job right. That's what's in the best interest of the business. It may not be the best interest of a middleman. What Michael James has is, this wonderful video he has where he talks about team output owners. And if you don't fix your organizational structure, because structure drives culture, you're going to have team output owners, and they're going to drive these kind of problematic behaviors. But that's a symptom of an organizational design issue, which LeSS directly goes after better than any other. The thing is, LeSS is not just a framework. LeSS is this whole, let's design an organizational design that it's aligned with our system optimization goal, which is to say we are optimizing at a global level for adaptability and thereby value delivery to the customer. And we build an organization design that achieves that. And then when you do that, everything gets better, and it gets better fast.
James Carpenter, thank you so much for coming on the show and for bringing us through your LeSS-Huge case study in hardware. It was really, really interesting. It was took me a couple of hours to read the case study. It's worth reading, and it's really honest about the challenges that you came across, what you learned, and some of the good things you. Not only did you show the feature team adoption map when you started, you also showed the progress that you made later on, and the progress across the organization as well in terms of transitioning people and so on. So that was really, really cool to see. It would be remiss of me not to mention that you've got a class coming up in Dubai. I've been sending messages out during the show, but there's a certified LeSS practitioner in Dubai, 14th to the 16th of March. And you can register at agilecarpentry.com/CLP/Dubai. If you would like actually to receive training from James in some other location, maybe you could fill out the survey bit.ly/CLP James. And there's a few questions there in terms of what you could do, but you could also just email James at agilecarpentry.com. It's probably the easiest way to get in touch with James and let him know. I really, really enjoyed the case study. I really got a sense that James is a person that I would want to be trained by. I've been trained by lots of trainers in the LeSS community, and I get a real sense of confidence from James' work, the case study, and also from what I heard in the show as well. So I want to thank you so much, James, for coming on the show. Any closing comments that you'd like to bring up?
Just to comment on the training. So some of these trainings I list in an area and hoping that I'll find enough people. Oftentimes I find people have to get approval in order to come. So, and they don't actually formally sign up until they have that approval, please let me know ahead of time. Like once you're saying, I'm going to try to go, as soon as you decide, hey, I'm going to try to go, please let me know so I can kind of help. That helps me manage scheduling and such. It also gives me an opportunity that if there's somebody that you need to convince, I would be happy to do a course walkthrough or have a conversation, or we could talk about this case study. Whatever it is that you think would help get whoever you need to say yes to yes to be able to go, I'm happy to do that. And we can even talk about private course anywhere that you need it. And I would be more than happy to, I'm set up to basically go anywhere in the globe and take the materials I need, but have a whole logistics chain to make this possible. So please let me know if you want a course, where it is you want it, and also let me know. And I'm doing the in-person. I'm focusing mostly on the in-person, CLP.
Thank you
So
so
yeah,
much.
just please let me know early so that I can know and so that I can help you.
Cool. So whoever joined this late, a few people just joined around now, and this is recorded. So the link that you used to look at this live, well, you can watch the recording later on as well with the same link. Oscar, thanks for your message. Love the channel, the live stream. This is the start, but we'll catch it up later. Keep up the awesome work. So thank you so much, James, for coming on the show. And
thank you for having me.
Thank you.
You're doing a wonderful job, John. It's a privilege to be in your hands. So.
Thank you so much, and have a good day, everyone, and enjoy the rest of your day. And I'm sure it'll be wonderful. Seeing more or less around the world would be not a bad thing. Thanks, everyone.
Perfect.